Hi everyone, I'm really happy to see you, and it's been quite a few weeks. So I've been working on this programming thing that I want to introduce you, so I hope you get the best out of this course today. So, let me introduce you to programming. So programming, it is just giving a set of instructions to a computer in order for it to solve a problem. So that's why we solve problems with computers. So there are many use cases for that. For example, we can open and close the door automatically with programming, and we can also turn the lights on and off with two claps, like this. And we can also use face recognition. And also, we can have many different combinations of whatever sensors and computing power we have in order to have a result. So before programming, we need to have a problem, right? Because if we don't have anything to program, then there is no reason for us to program in the first place. But when we have a problem, and when we see that we can use the computer to solve that problem, then we will use programming to make the solution. And we must anticipate the result that we want to have. And then, and only then, we will write the instructions. And it's really that. It's really writing instructions. And programming is a process of creating computer programs. So in fact, it's really there. It is really writing. We create by writing, just by how God created the world, just by speaking. You may have already heard about algorithms, and most of the time the line between algorithm and program is blurred. And so an algorithm is often expressed with a notation that is independent of a programming language. So it's the same instructions, but it's expressed, not linked with any programming languages, but it's just your native language, and you write the instructions. Like, I want this door to open when this happens. And that's the algorithm. And then we will just use programming to transpose or use the instructions we created with the algorithm, and we use the programming language to program that instruction on the computer for it to execute it. If I was a computer, for example, and I speak Malagasy, by the way, Malagasy is the language spoken by people from Madagascar. Yes, I'm from Madagascar. Yay! And so, if you speak Malagasy, you will be able to ask me whatever you want if I was a computer, and I would do it. So, let me demonstrate this to you. Okay? You see? Just like that. If there is a Windows machine and you open the command prompt, you'd be able just to put the command shutdown-s and it will shut down. That's not really helpful, but it's just to show you that there are commands like this used by the languages on which they're written, and They just do the thing you ask them. What we've seen them is can be said as a comment. My friend asked me to massage him, and we talked about a Windows machine to be shut down. And that doesn't really solve a problem for us because there are easy commands for this. But in order to have an algorithm or a program, we need to have a problem that's worth programming. For example, if we talk about the massage thing earlier, we can have something like, I want to have a massage at these set times, or I want the computer to shut down when I think that it has to shut down. That can be helpful. But how to do that? Well, that's the problem. If you can do it, well, just share. And so, in general, if our problem could be solved with a single action, we won't need a program in order to solve it. But most problems have conditions and constraints involved. So let's see how we should write the solution. Let's look at a problem. So I want to use facial recognition to unlock and open the office door, for example. So the simplified version would be when someone from outside is near the door, do a facial recognition. And when the person in front of a door is part of my team, open the door. And after they enter, close the door. It would be awesome if we could just say that and it just happens, right? And we can. And this would be a project that I will code along with you, and I will show you the process in order to do this. Of course, we will have sensors, cameras, and a servo to open the door and close it. The instructions that I gave earlier, it's really it. That's the whole algorithm. Of course, it can be, it can have more depth and more layer to it. But right now, that's really all you need. But later, when you will need to create documentations and patents, there may be more detailed versions in order to produce these documents. But right now, in order to program what I just said, that's really all you need. Okay, so let's make the previous example into a practical one. Like the command I showed you earlier, shut down, shuts the computer down. We didn't need to interact with the processor or the RAM or the power or whatever. All of the interactions behind the word shutdown is already there. We don't need to say we want the RAM to empty, we want the processor to stop working, and so on. It's already there. With most tools, there are already pre-made interfaces for us to use freely. Awesome, right? And that's for most things, I'm telling you, that's just thinking about it amazes me. It's so awesome. And I hope you will find it awesome too. Let's assume that our door have pre-made features. When we are going to code this, we are going to code these features that we call pre-made here. But let's just say here, for the simplicity, let's say that our door have features like open the door, that will open the door, and close the door, that would close the door. So when do we need to open the door? When the person in front of it is from my team. So let's break that down. Let's say if someone is in front of a door, so in order to know that someone is in front of a door, we would need a proximity sensor, right? So let's say that we have the proximity sensor. So the proximity sensor would tell us that someone is in front of a door. So to keep it short, let's assume that we have a feature called someone is there from the sensor. So far we have when someone is there and something else beside it, open the door. Oh, it's already so exciting, right? So next, we have to test if the one in front of the door is someone from my team. Here, my team needs to be some data that we already have, right? Because we can't compare the data of the person outside the door with nothing. We have to compare it with a face data of everyone in my team. And so we would need a camera. The camera, let's assume that it has the function capture faces. So with my camera, we will just need to capture the face of the someone who is in front of the door and then compare it to the face data of the people from my team. As the time goes, we need to store the face data of the person in front of a door into a variable. The reason we need to do that is that when I am in front of a door, my face would be inside the someone variable. And if it's someone else, then their face will be inside the someone variable. So that's why we call it variable, because it can change, right? And so what we need to do is just, when someone is in front of a door, put their face, that's possible, right? Yeah. Put their face inside the variable someone. And then compare it to the data that's already there for all the people from my team. So if we have a match, open the door. So far we have when someone is there, someone equal capture. In almost all programming languages, I want to say all programming languages, equal means assigning. So we want to assign the captured data from the camera to the someone variable. So every time someone is there, the face data of that someone would be captured and put inside the variable someone. To test that he or she is one of my team, we can just write if someone, the someone that we just captured, if someone in my team, and that's really how we write it in most programming language, but this is like just basic English instructions that we have here. If someone in my team, easy, right? So then we will do something. So next we have, when someone is there, then capture their face. And if that someone is in my team, open the door. Ah, awesome. Beautiful. Let's stop there for now. And don't worry, I will really implement that program for my door. And I will show you step by step what I've done and what are the things that need to be taken care of. And so you just need to stay tuned to the channel in order to see the result of this program. And if you want to support, you're welcome. Thank you very much. That's it for today, guys. I hope you've enjoyed today's course. And let me know if you did. Put a comment below and hit the like button. And don't forget to subscribe if you haven't yet. I don't know, right now there are about maybe 14 subscribers. You can help me out here. And that's it. See you in the next video. Bye.